Hi folks, Dr. P here. This is assignment question 14 from the probability assignment. So let A and B be events with the probability of A equaling 0.6, the probability of B equaling 0.4, and the probability of A and B equals to 0.3. So we can write this last statement here using set notation as probability of A and B, so that it's an intersection, equaling to 0.3. In A, they want us to determine the probability of A given B. This vertical line is read as given. This is conditional probability. This is conditional probability. And it means, what is the probability of event A occurring if B has occurred? Okay. So here we're going to be using the multiplication law for dependent events. So we're going to be using the multiplication law for dependent events. And it'll be probability of A and B equals the probability of B times the probability of A given B. So here what we do know is we know what the probability of A and B is. It's 0.3. We know that the probability of B is 0.4. So we can just plug in those two numbers and then we can solve it for the probability of A given B. So it's going to be 0.3. Probability of B is 0.4 times the probability of A given B. And now we just solve for this. So we're going to get the probability of A given B as 0.3 over 0.4. Now we never want to leave a quotient with decimals in the numerator and the denominator. So this can be simplified to 3/4. Just multiply numerator and denominator by 10. All right, so that is A. In B, now we want to find out the probability of B given A. So we're going to be using, again, the multiplication law for dependent events. This time, the event B depends on A having occurred. So it's going to be looking like this. So the probability of A and B equals the probability of A occurring times the probability of B occurring given that A has occurred. And so we're looking for this term here. We know the probability of A occurring, it's 0.6. Excuse me. And we know the probability of A and B occurring, it's 0.3. Excuse me. Just plug in the numbers. So 0.3. Probability of A is 0.6. And we just solve it for the probability of B given A. Which is going to be 0.3 divided by 0.6. And again, we don't want to leave those decimals. So we can multiply numerator and denominator by 3. Which is going to give us 3 over 6, which can be reduced to a half. And then in C, we want to find out the probability of A or B. So event A and B are not mutually exclusive. Why? How do we know that? Well, we know that because the probability of A and B is not equal to 0. It's equal to 0.3. So both events can occur. And the probability of both events occurring is 0.3. So in this case here, we are dealing with not mutually exclusive events. Mutually exclusive events. Which means we're going to be using the formula for not mutually exclusive events, which is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So we know the probability of A, we know the probability of B, and we know the probability of A and B. So it's just a matter of plugging in the numbers. So probability of A is 0.6. Probability of B is 0.4. And the probability of A and B is 0.3. We evaluate the right-hand side here, and we're going to get a probability of A or B to be equal to 0.7. I hope that helps. Until next time, may the math be with you.